Hello everyone. This is in continuation to our topic analytical geometry. This is question 5 where we need to show that the points 5, 1, 1, -1 and 11, 4 lie on a straight line. So let us first consider, let A be the point 5, 1, B be the point 1, -1 and C be the point 11, 4. Now let us find out what is AB. AB will be square root of 5 minus 1 the square plus 1 minus or minus 1. It becomes 1 plus 1 the square. So let us calculate this. 4 square is 16. 2 square is 4. So we get root of 20. Root of 20 can be written as root of 4 into 5. That can be rewritten as 2 root 5 units. That is the distance between points A and B. Now let us find out what is the distance between B and C. Distance between B and C will be 1 minus 11 the square plus minus 1 minus 4 the square. That will give us minus 10 square is 100, minus 5 square is 125. That is nothing but root of 125. Root 125 can be written as 25 into 5. That can be simplified as 5 root 5 units. So that is the distance between B and C. Now let us find out CA. CA will be square root of 11 minus 5 the square plus 4 minus 1 the square. That will give us 6 square, which is 36, and then 3 square, which is 9. So it is root 45. Root 45 can be written as root of 9 into 5. That will give us 3 root 5 units. Now we may notice that sum of this distance from A to B plus sum of the distance from C to A is 2 root 5 plus 3 root 5, which will give us 5 root 5. And 5 root 5 is nothing but BC. Therefore, we can say ABC. The points ABC lie on a straight line. Lie on a straight line. That is the solution for this question. In continuation to our analytical geometry, this is question 6. Show that the quadrilateral with vertices 3, 2, 0, 5, minus 3, 2, 0, minus 1 in this order is a square. First, let us construct a quadrilateral. And let us assume this as A, this as B, this as C, this as D. In that order means A we will consider as 3, 2, B we will consider as 0, 5, C we will consider as negative 3, 2, and D we will consider as 0, minus 1. In order to prove that it is a square, we need to check whether AB is the same as BC and BC whether it is same as CD, CD whether it is same as DA, and also to check about the diagonals, that is whether AC is equal to BC, BD or not. These are diagonals, whether the diagonals are same or not. If this as well as this is proved, then we can say that this quadrilateral is a square. So first let us find out what is AB. what is AB? 3, this one and this one. So 3 minus 0 the square plus 2 minus 5 the square, which is root of 3 square is 9 and this is minus 3 square is 9. So it is root of 18. I will say root 18 units. Now let us check about BC. It is square root of 0 minus or minus 3 plus 3 the square plus 5 minus 2 the square. So 3 square is 9. Again 3 square is 9. So this is also root of 18 units. Let us now check about CD. CD is square root of minus 3 minus 0 the square plus 2 minus or minus 1. So 2 plus 1 the square, which is equal to minus 3 square is 9 and 3 square is again 9. This is also root of 18 units. Now let us check about DA. DA distance will be 0 minus 3 the square plus minus 1 minus 2 the square. So we get minus 3 square is 9, minus 3 square is 9. So this is also root 18 units. So we have found, therefore, AB is the same as BC is the same as CD is the same as DA. So one part is checked. Now let us check the diagonals AC. AC is equal to 3 minus or minus 3. So 3 plus 3 the square plus 2 minus 2 the square. So this becomes 6 square, which is 36, and then 0. So you get root 36 is 6 units. Now let us check what is BD distance. Distance between point B and point D. 0 minus 0 the square plus 5 minus or minus 1. So 5 plus 1 the square. So this is 0 plus 5 plus 1 is 6 square, which is 36. Again, this is root 36, so 6 units. So therefore, we can say AC is equal to BD. Hence, ABCD is a square because it satisfies all the conditions. That is the solution for this question.